So we're going to go through the true and false questions first. First question asks, for a two-sample independent group means hypothesis test, you would use a paired test. The key word here is independent. So what we're looking for is we want to find someone in the first group we can compare with someone in the second group, so we can subtract them and find the difference for a paired test. However, since they're not independent, we can't pair them up, so we wouldn't want to do a paired test. So this one would be false. What we would want to do would be a two-sample t-test, where we just compare x bar 1 and x bar 2, the two different sample averages from each group. The second question says, a student's t-distribution is the same as a standard normal, except the t-distribution is wider. And that's exactly correct. Our t-distribution depends on the degrees of freedom, and the larger and larger the degrees of freedom, the closer and closer to the normal a t-distribution is going to be. But a t-distribution is always wider than a standard normal. 3 says, the alternative hypothesis proposes what we should conclude if we find the null hypothesis to be unlikely. So what this means is that we reject our null hypothesis. And if we reject the null hypothesis, then the only thing left to conclude is the alternative. So that statement's true. 4 says the hypothesis beta is equal to 0 is the same as stating that there is no linear relationship between x and y. This is close, but not quite right. It's not beta 0, it's beta 1, because this is our slope, and beta 0 is our y-intercept. So beta 1 equals 0 is this no relationship between x and y. The next one says, the larger the p-value, the stronger the evidence the sample gives. So the stronger the evidence indicates we want a small p-value. Because the smaller and smaller the p-value, the more and more unlikely our sample would occur if the null hypothesis is true, which is stronger evidence against the null hypothesis. So this statement is also false. It says, lowering the significance level decreases the chance of a type 1 error. And that's true. The probability of a type 1 is just equal to our significance level. So if we lower our significance level, we lower our chance of committing a type 1. However, it says, and a type 2 error. Lowering our significance level increases the chance for a type 2. So this statement is also false. Next one says, for a chi-square test, the assumptions conditions to check include count data. So that's what we want to check. We want to make sure that we're dealing with counts, just how many people in group 1, group 2, group 3, group 4. We still have a randomization condition. Then asks if we want our success failure. So the success failure is for a proportion test. So either a 1 proportion z-test or a 2 proportion z-test, not for a chi-square test. What we replace with the success failure condition is with the expected cell frequency. So we want our expected counts to be greater than or equal to 5, not our success failures to be greater than or equal to 5. So this statement is also false. The next one says the significance level of hypothesis test is also called the alpha level. Well, our significance level is equal to alpha, so that statement's true. And then the last statement says the p-value is the probability that the null hypothesis is true. And this one's false. Our p-value is the probability that our sample would occur, or something further away from what we expect to see, if the null hypothesis is true. So we're assuming the null hypothesis is true, and then we're calculating our p-value. So that statement is also false.